did, I think. So can you guys please work on question number 2, please? Question number 2.
Is that like a standard exam question?
Yeah. It's a standard exam question, yeah.
Like with the conditional CBF3 and stuff as well?
Yeah. Yes, you will get a question like that in the exam. I think every past exam paper has a question like that. So you Veronica, she's online today. She's not coming. I don't know. I'll give you a few minutes and see if you can do it. I'll show you how to do it. Yeah, by the way, next week is revision week. So on Wednesday, we will have a revision session. So please bring all the questions you guys have on the material I covered. Of course, you can also contact me before, anytime, 24/7, about questions you have, right? And on next Friday will be a tutorial session. Yeah. Okay. Alright guys, let me show you, if you haven't done it, let me show you how to do question 2. Right, I think I did question 1 as part of a video, or one of the videos you need to. So this is question number 2. So the, you should say G bar, not F bar, that's a mistake. Sorry, you should say G bar equal to exponential of alpha xy divided by x plus y minus x minus y. Now, what you need to realize is that I gave you 4 representations the other day, right? Now, you need to work out which of the 4 representations this can be put into. So to do that, because it was G bar, right, the only representation that involves a survival function is the last one. And for that, you need to make sure that the marginals are exponential. So let's put y equal to 0. You get e of minus y. And if you put x equal to 0, you get e of minus x. So hence, these two imply that alright, these two imply that the marginals are unit exponential. Right? So what we need to do is we need to express this in the form of the fourth representation. Right? To do that, I'm going to show you what to do. So you say, you put, right, this thing here, you need to pull out x minus x plus y, because if you remember in the representation there is a minus x plus y, right? And in brackets, what you're going to have is the following. Okay, it's going to have is the following, right? So this you can write as okay, you can write like this, right? Are you guys following me? You've done these questions, have you? Okay, good. Okay, so this is the representation that I gave you last week. It's namely representation number 4. And so what you have is that the function, remember, this has to be in the form a of, is it x or y? I can't remember. Anyway, I think it's x.
It's y.
Is it y? Was it y? Yeah, sorry. It's not going to make an awful lot of difference. X plus y.
So this is like one of them is like one minus the other.
Yeah, okay. So in any case, yeah. So this must be in this form. So your a function is, it must be minus alpha 1 minus omega plus 1. Alright, so this is your a function. Alright, let me write it more neatly. So this is 1 minus alpha omega 1 minus omega. Alright, now we need to check whether this function satisfies the 4 conditions. The 4 conditions that we need to check are that number 1, so let me call this 1, that a of 0 must be 1, and number 2 is that a of 1 must be 1, and number 3 is that right, okay, all right, and this to check this condition, you can do it in 3 parts. First, that a of omega is less than or equal to 1 for all omega, and the second is that a of omega is greater than or equal to omega for all omega, and the third condition is that a of omega is greater than or equal to 1 minus omega for all omega. Alright, and finally condition number 4 is that a is convex. Alright, so we need to check all these guys, right? We need to check all of these conditions, right? So let's start with the first one. You guys with me? I don't know why the sound is not working. I can hear you. Ah, good. I heard. Thank you. Thank you for hearing me. All right. So let's start with condition 1. So a of 0 is 1 minus alpha times 0 times 1 minus 0, right? Which is clearly equal to 1. All right. So this condition is satisfied. Part 2. A1 is 1 minus alpha times 1 times 1 minus 1, which is once again equal to 1. So condition 2 is satisfied. Now to check condition 3, we need to check each of these conditions, alpha, beta, gamma. So let's start with alpha, which says that A of omega must be less than or equal to 1 for all omega, right? Which implies that 1 minus alpha omega times 1 minus omega is less than or equal to 1 for all omega, right? So, and this is the same as saying that minus alpha omega 1 minus omega is less than or equal to 0 for all omega. And this is true. This is true because alpha is a positive number, although the question doesn't say that. Alpha is positive, omega is positive, omega is also lies between 0 and 1. So this statement is true. Okay, guys? All right. Now beta, condition beta is that we need to check whether this is the case. Yeah? So that means 1 minus alpha omega 1 minus omega is greater than or equal to omega for all omega, right? So this is the same as saying that 1 minus omega minus alpha okay, and this is the same as saying that 1 minus omega times 1 minus alpha omega is greater than or equal to 0 for all omega. And this is true because this guy is non-negative, right? And we have to assume that alpha is less than 1. This is also non-negative if alpha is less than 1, and we have to assume that alpha is less than 1, right, and greater than 0. Although the question doesn't say that, we need to assume that, right? Okay, so that's now gamma. Okay, so the 1 and the 1 cancels, so this becomes minus okay, and now if you cancel out the omega, because there is a negative sign, you need to change the sign. All right, and this is true. This is true because this is not this is a number between 0 and 1, right? It's from 0 to 1, and this is also a number between 0 to 1. All right, so therefore this statement must be true, right? Okay, guys. Now finally, so we've done, so condition number 4 is to check whether A is a convex function, and I told you how to check that a function is convex or not. What you do is you first of all you take the first derivative. The first derivative is minus alpha plus 2 alpha, correct me if I'm wrong, omega. The second derivative is 2 alpha, which is positive, right? So condition 4 is satisfied too. So hence the conclusion is that hence Alright, so this completes the first part of question 2. The remaining parts are trivial. I'm not going to do them. I'll just show you what the formulas to use. So it's only the first part which can be non-trivial for you. So to do the remaining parts of question 2, so part B is to find the joint CDF, which is G of x comma y, right? Yeah, and you may recall this is a formula I gave you a long time ago. I mean, not long time, I mean, it may be a long time to you, but this is one of the formulas I gave you some time ago, right? That is the relationship between the joint CDF and the joint survival function. You should look back, right? So we know that this guy is exponential, and this is also exponential, and this is given in the question, which is plus e alpha x y divided by x plus y minus x minus y. So that's part B. Part C is to find the conditional PDF of y given x. So to do that, you just conditional CDF. So we just divide g of x comma y by the density function of x, which is this. Right? This is what you need to do. That's part C. Part D is the same thing, but you divide by the PDF of y, which is this. And part E is the joint PDF. To find the joint PDF, you just do a double partial derivative of the joint CDF, right? And part F is the conditional PDF of y given x. So it's gonna be, let me call this little g, okay? Let me call this little g of x, y. So it's going to be the conditional, the joint PDF divided by this, right? And that's FG. Part G, the final part, is the conditional on y. So this is going to be this. So it's just a matter of using this formula. So there's nothing, it's just routine, right? I'm sure you guys can do this, right? All right. Any questions on this? You guys okay in the Zoom? You have any questions? Let me write. guys on the Zoom? Can you hear me? Okay, can you do the next question, please, which is question 3 on the tutorial sheet. Question number 3. So question 3 is this guy here. So you should, by the way, this should be G, not F. That's a mistake. All this should be G bar, not F bar. All right. So G bar is given by this, and the questions are the same. On the next page, the questions are pretty much the same. Okay. Yeah. Because the side parameter can take any value on the real value. Yeah, but we did this before. This is GDB distribution where the shape parameter can be negative, can be 0 or positive.
But there's this whole thing, there's a question here from us to say that x is bigger than -1 on the side.
Yeah, but it doesn't say anything about the sign of side. This is just the support of the CDF. The side can be anything.
Yeah, but if you just put like a minus sign to that, then what equates to that all. So why wouldn't you split it to like it's just an equation for side, which can be not just whole for all sides. Therefore, when you split it, you can take it.
Yes, it can be done. It can be done without splitting. Yeah. It's the same for all. Yeah. So yeah, if you are, can be done for. The 0 case is different, but with other.
With the dots,
Yeah. Yeah. The 0 case is different. But it's the same. Yeah.
how do where does this CDF come from? That side to is that like a known thing? Can I work out?
Yeah. Then what I think I did this when we talked about the GV distribution, I showed you how to get it. It's just using the fact that
fact that 1 plus that,
100% overrunning.
yeah, all of that, and all of that, and plus the E of that.
Okay, and then you use the set of the side of the
Yes, I equal to, so you need to,
I mean,
you need to set this to be an N. You need to set this to be an N, right, so this will become E of minus 1 plus x to our N of minus N.
and then just write all of the power minus 1.
Yeah, and then you apply this one. And using this also, you get E of x minus 1, which is
Alright guys, had you done this? I mean, it's not really hard. Number 2, question number 2. Sorry, number 3, I mean. Question 3. So this is question 3. You have G bar equal to okay. So once again you put y equal to 0. If you put y equal to 0 here, you get e of minus x. And if you put x equal to 0, you get e of minus y. And both these are unit exponential marginals. Right? Marginals. Right, now this you can write it as g bar of x comma y times e of minus x plus y. Then in brackets you have this, yeah? You following me? Okay. Now this you can write as further as e of minus x plus y 1 minus y over x plus y okay. And this is clearly equal to something of this form. Right? if A of omega is equal to 1 minus omega to the power A plus omega power A. Alright, so this is the function for A of omega. Now let's check the four conditions. The first condition is A at 0. A at 0 is 1 minus 0 power A plus 0 power A to the power this, and this is clearly equal to 1. Okay, so condition 1 is satisfied. Condition 2 is A at 1, which is 1 minus 1 power A plus 1 to the power A, and this is also equal to 1. Okay, and condition 3, okay, in order to check condition 3, we need to check alpha, beta, gamma. Alpha is that A of omega is less than or equal to 1, right, for all omega, which is the same as this, yeah, and this is the same as saying that okay, which is the same as saying this. Now this is true because W is a number between 0 and 1. So, and if you assume A is greater than 1, if A is greater than 1, then W to the power A will be less than or equal to 1, and 1 minus W to the power A will also be less than or equal to, will be less than or equal to, I meant to say omega, 1 minus omega, right? Right, if we assume that A is greater than 1, which is, you can't do it without this assumption, right? Both W is a number between 0 and 1, and therefore if you power that to a number that is greater than 1, has to be less than or equal to this, and the same here. So you should sum these two, that is W to the power A plus 1 minus W to the power A is less than or equal to omega plus 1 minus omega, which is 1. So this condition is satisfied. You guys okay? Right, now beta, that's alpha. The beta, to do the beta part is not difficult. You see, okay, which is the same as saying that yeah. Now if you take the power both sides, this will become okay, and now these two guys cancel out, so this becomes and this is clearly true because 1 minus omega is a number between 0 and 1, and A is a number greater than 1, so this is true for all omega. Now that's beta. Now gamma, which is the same as saying that right? And this is the same as saying that okay. All right, now these two guys cancel out. So what you have is w to the power omega greater than or equal to 0 for all omega, which is true once again. Okay. So alpha, all three are satisfied. Okay. The final condition is to check that whether A is convex or not. Right. Now, okay. Let me write down one more time that A of omega this is your A of omega. Now, to check whether this is convex or not, you need to take the second order derivative. All right, so let's see. So the first order derivative is, you should do the math, correct me if I'm wrong. Derivative with respect to omega. So there's a minus here. Okay, like this. And this simplifies to the A and the A cancel, so this becomes okay. Alright guys, so this is the first order derivative. Hopefully it's correct. The second order derivative is, you need to use the product rule, right, to do the second order derivative. So let's see how we can do this. Times A times this, yeah, and then plus sorry, excuse me. This is 1 minus omega A minus 2. Okay, so this is what you get. Now, you need to simplify this, and I don't think I may be running out of time, so let me show you. After some simplification, this is what you will get. I'm sure you guys know how to do the simplification. After some simplification, you will get the following, which is A minus 1 times times this, right, multiplied by, in brackets, squared, right, then plus this times all right, this is what you will get. All right, now you will see that A is we are assuming that A is greater than 1, so this guy here is positive, and this guy is obviously positive, right, because omega and 1 minus omega are between 0 and 1, and this one has to be non-negative because you have a square. Remember, anything squared has to be non-negative, and this guy here is positive, and this guy here is also positive. So hence the second order derivative must be positive for all omega. So hence we have proved that A is a convex function, right? And hence we have shown that all conditions are satisfied, and that, let me write it down, hence G bar corresponds to bivariate extreme value distribution. All right. Okay, so that's the first part of question 3. The remaining parts are similar to the previous question that I did, right? Are you guys okay with this? So it just you had to be a little careful with the second order derivative, and it's just manipulating it so that you can show that it is positive for all omega, right? Any questions from the Zoom guys? Are you guys okay? So as I said, next week we will have a revision session on Wednesday from 10 to 11, and you also have the in-class test. I sent you guys a reminder this morning about the in-class test. The in-class test will begin at 1 p.m. UK time on Thursday, 16th of December, and it will finish at 1 p.m. UK time on 17th of December, right, which is a Friday. So you have 24 hours to complete the in-class test and upload them. So you should have no excuse 24 hours is plenty of time for you to complete and upload the answers. By the way, there will be no tutorial next week, so because of the test, I cannot have a tutorial at the same time. So I forgot to mention that. I will mention it in my email later on. There will be no tutorial on Friday, but instead you have the in-class test. You should complete by 1 p.m. on Friday. Okay, so please, but you will have a class on Wednesday, which is about revision for this course. Anything or everything I have done. Please bring any questions to me. Of course, you can also email me 24/7 or Skype me or Zoom me to ask all your questions you have, right? And I will let you, I don't think I have received the exam date yet, but as soon as I receive a date and time for the
27.
is it?
Well, yeah, someone like the evening sent it around. That hasn't been like made official, but apparently 27 January.
Okay. As soon as I get to know the exam date and time, I will let you know, guys. And of course, I mean during the break also you can email me any questions you guys have. I'll be around during the break, so in Manchester. So feel free to contact me 24/7. Right. Anyway, okay. Have a good week, and I'll see you guys on Wednesday next week. Okay. And take care of yourself too. You want to see me?
No, I mean, I will next week.
Okay. All right. See you guys. Have a good weekend.